Hi, this is Bob Pryor, and I'm going to talk to you today about our Math 65 midterm review, chapters 1 through 4. Let's get right to it. Number 1 asks us to do some rounding of numbers. And we're going to round this large number to the nearest 10,000 in 1A. There's the 10,000s place. I'm going to circle the rounding digit. A 3 tells us to round down. And so that requires us to rewrite this as 197 followed by zeros the rest of the way. And the answer is 1,970,000. In 1B, we're asked to round to the nearest 100,000. This time, though, the rounding digit 7 is higher than 5, and we must round up. That means adding 1 to the place digit, and because it's a 9, it will carry over to the very next number, and we actually end up getting 2 million with everything else being zeros. So we could think of the 19 plus 1 as 20, and then everything else is 0. On number 2, we see the property that 5 is equal to 5 plus 0. This is called the identity for addition, because anytime you add 0 to a number, it doesn't change the value of the number, or it doesn't change the value of the expression that we have. It's still 5. In number 2b, whenever we have multiplication or addition, in this case it's multiplication, and we can switch the numbers around, that is called the commutative property. So this is the commutative property of multiplication. Numbers 3 and 4 are based on a bar graph that we can see, and this is for contributions raised during a campaign for a mayor, Alexis Bowler. And what we're asked in number 3 is to identify how much more did the candidate receive from business groups than from fire and police and fire groups. Now, how much more means a subtraction. So we have to look at the business groups. Let's see, that's right here, business groups, BG, and that value is $15,907 raised. And how much more did she receive than the police and fire, which you see right here is the PF, and that number is 6,986. So we must do some subtraction to find out how much more she did, how much more she received. And you can see that we have a sentence for our answer. She received $8,921 more from business groups than from police and fire groups. Number 4, how much in total contributions did Ms. Bowler receive? That requires us to consider all of the amounts that she received from various groups, and we have to add these all together. I've taken the time to write these down ahead of time, and it's simply a matter of adding things together. And we again write this because it's a word problem, we write it as a word answer. And we see here that she received a total of $62,164 in contributions. In number 5, we're asked to find the area of a rectangle. Now, a formula for the area of a rectangle is that area is equal to length, L, times W, width. And it doesn't matter which number we put up above. I'm going to write 27 and 15 and multiply. 405 square inches. Either way is fine. Number 6. Here we are asked to expand 3 to the 4th power and then find its value. Now 3 to the 4th means 3 times 3 times 3 times 3. And we could multiply these one at a time, but we do have the chance to make it simpler on ourselves and multiply the first two 3's together and then multiply the second two 3's together. And then we'll multiply everything together at the end. So 3 times 3 is 9, times the other 3 times 3 is also 9, and this is 81. We'll put a box around that. So 3 to the 4th power equals 81. Number 7 says the 48 employees of Miller Inc. pooled their money and bought a lot of lottery tickets. Well, the bottom line is that in the end they won a total of $7,296, and they have to share this evenly. It says here, divided evenly among those 48 employees. So this is indeed division. Let's see what we get. 48 divided into 7,296. Now 48 will not go into 7 at all, but it does go into 72 one time. 1 times 48 is 48, and we subtract. And when we do so, we get 24. We bring down the number 9 so we can continue to divide. Now at this point it's very hard to tell what 48 by itself, or as it is, goes into 249 how many times, but if we do a little rounding, 48 is close to 50, and 249 is close to 250. So it's as if we were doing a mini division problem, 50 divided into 250, and 5 into 25 goes 5 times. And so we will expect that 48 will go into 249 5 times. It might not. We might be off more or less, but let's try that first. 5 times 8 is 40, so it's 0. Carry the 4, we have to remember that. 5 times 4 is 20, plus that 4 is 240, and yes, this was a good choice. 9 and 6. 48 is close to 50, 96 is close to 100. I hope it goes in 2 times. 2 times 8 is 16, there's 6. Carry the 1. This time we want to add 1. And 2 times 4 is 8, plus the 1 is 9. And when we subtract, we get 0. That's great. So 48 divides evenly into 7,296, and it divides in 152 times. And you can see over here how that answer appears. Each employee will receive $152. Number 8. Of the following numbers, determine which are prime, composite, or neither. The prime numbers are the ones that are divisible by 1 in itself only. And I know that 2 divides itself only 1 times 2, and 43 the same thing, 1 times 43. So those numbers are prime, 2, 43. Let me get right to the number 1 here. 1 is not a prime number, it's not a composite number, it is neither. Even though it's divided by only 1 and itself, those two numbers need to be unique numbers. Like here it's 2 times 1, and here it's 43 times 1. But 1 times 1 doesn't count in that unique regard, so we consider this to be neither. 9 can also be not only 1 times 1, but 3 times 3. 42 could also be 6 times 7. And 115, I don't know what divides it, but I know that because it ends in 5, 5 is also a factor. Actually, that's 5 times 23. But those are composite numbers, 9, 42, and 115. And what we're using to determine some of that is called rules of divisibility. So we can use these rules of divisibility oftentimes to determine whether a number is prime or composite. Not for everything. And as you can see, that's in section 1.6. So you can make sure you read up on that. For numbers 9 and 10, again, rules of divisibility, or the divisibility tests that we see for numbers 2, 3, and 5 determine, we don't need to actually do the division, but 170, what factors, or does 170 have among these three factors, 2, 3, and 5? We're not interested in anything less than or greater than 2, 3, and 5, just those three numbers. Now for 170, it's an even number. So I'll say it's even because it ends in a 0, and that means that 2 is a factor. Also, because it ends in 0, 5 is a factor. 5 is a factor of every number that ends in 0. Now 3 is not a factor, and that's because if we add the 1 plus the 7 plus the 0, we add those digits, it equals 8. And because 8 is not a multiple of 3, this is a test for 3, 8 is not a multiple of 3, it doesn't, 3 is not a factor of 8, 3 is not a factor of 170. So the only factors we have are 2 and 5. For 528, right away we can eliminate 5 as being a possible factor because this number ends in 8, not 5 or 0. So 5 is out of the running. It is even, so that means that 2 is a factor. Now what about the 3? Let's add up the digits. 5 plus 2 plus 8. Now that adds to, see, 7 plus, let's 2 and 8 first. 2 and 8 is 10 plus 5 is 15. 15 is a multiple of 3. In other words, 3 is a factor of 15. So therefore 3 is also a factor of the number 528. And the answer here is 2 and 3.